by the way, while Miss Courtney's going over this, I do need your graphic organizers out because I asked you to get that out so I can collect.
Okay, so most people said that the main defining operation in this is the absolute value. But can somebody tell me like why it's the absolute value?
Because we got the absolute value sign.
Okay, so those absolute value symbols let us know that that's the defining operation. So Mr. King, is there like a mathematical term for those symbols? Like a
I literally just call them the absolute value symbols.
okay. Okay. And then so talking about the transformations applied to this function. Okay, so 2 units right and 3 units up. Okay, so like let's look at this. So remember when we're talking about translations, the location of what operation matters here for translations.
Addition and subtraction.
Okay, so the addition and subtraction. So Kyle, if I was moving up 3 units, what would that look like in an equation?
Plus 3.
Huh?
Plus 3.
If I was moving up 3 units,
Yeah.
what would that look like?
He said +3.
Oh, I'm sorry. I thought you said. I thought you said what's that?
I know. I had to think about what he said too, but he did say +3.
Okay, plus. Okay, great. +3, but where?
On the y-axis.
Right, but so like on the inside or on the outside of the main operation.
All of the outside.
Okay, so that would be a +3 on the outside, but we have a -3 on the inside. What's up? Oh.
I'll come back for it.
But we have a -3 on the inside of the main operation. So what direction does that indicate? Yes. So to the left or to the right?
To the right.
Okay. So how do you know it's going to the right? Okay. So right. And why do we have to take the inverse of what it says? Can somebody else tell me?
Because the absolute value means.
Well, it's not only the absolute value because we have to do the opposite with quadratic functions as well. So why do we have to take the inverse? Yes, ma'am. Okay, so I'm talking about for like horizontal. Yes, that is right about absolute value, what those symbols do, the numbers. But so I'm talking about we have to talk about this direction works in the inverse because all of our horizontal transformations, remember they act the inverse of what you would think they do. So then,
Is it because it's on the inside?
yes, because it's on the inside of what?
The main function.
The function's main operation.
Yeah.
Okay, so then also guys, what is this 2, what's happening between this 2 and the function's main operation? Okay, so if it's multiplying, what kind of transformation do we have? What did we look at yesterday on Desmos? Not talking about direction, just what kind of transformation does multiplication signify is going on? Say that again? No, I'm asking for a kind of, okay, dilations, right? So if this 2 is being multiplied times this, times my function's main operation, what kind of dilation would this be? Okay, and how do you know it's a stretch? Not only is it positive, remember guys, what makes,
Because the factor is greater than 1.
okay, the factor is greater than 1 makes it a stretch. So, do you remember when it would be a compression?
Under 1.
Under 1 or
Negative.
not negative, because remember, what happens if we're multiplying by a negative?
Or the same.
Okay, between 0 and 1. Okay, because remember if we have a factor that's between 0 and 1, what numbers are we talking about here? Right, like 0.5 is in there, fractions, anything between 0 and 1, but that's what, that multiplication of that value is what's causing the function to compress. Okay, so you have to remember what values cause stretching and which ones are causing a compression. Is there anything else from this question that you don't want to hit on?
No, I think that's it. And yeah, I'll look at the agenda with everyone, just so I want to go over a couple things. Really quickly, I need y'all to pay attention because I want to emphasize something. Quick show of hands if you just talked during that bell ringing class discussion. So 1, 2, 3, 4. How many students are in this classroom right now, though? Roughly 23. I need y'all to remember, the person who talks the most learns the most. And you can come up with all the excuses in the world of, well, I'm shy, or I'm antisocial, I have someone in here who says that, I have ADHD, I have this, that, and the other, but the fact of the matter is, if you're talking, what do you have to do before you can open your mouth about an idea? You have to what?
Think.
You have to think. And who's going to learn the most? The person who speaks the most, but thinks the most. Your speaking out loud is a sign of you actually thinking through these things. All right? That's not part of the reason. That is a big reason why I ask you to talk. I know that it can be scary because we can get things wrong. But also, is there anybody in here who has talked who has said it perfectly every single time?
I know I did.
Skylar doesn't. Does Anthony?
Mm-hmm.
No? So why are we scared to talk? You want to grow, you want to get better, you want to improve, you got to open your mouth because that's going to help, it's going to force you to think. Think about these ideas and talk about it. It's your choice, but I'll go ahead and tell you right here and right now. Second block, they scored, and we're going to talk about the test in a second for just a minute. Second block scored the highest, 100% on the test. You want to know what class I teach that talks the most about math? Second block. It's not a secret. Overall, the people who scored the highest on the test are the ones who talk the most. Okay? That's plainly put. That is true. You want to learn more, you got to talk more. Alright, let's look at, you already have the agenda up?
Yes.
Okay, I want to talk about dispositions about learning and growth. I need you to hear me very clearly on this. Because I know, and I haven't addressed this in a while, but I know the mentality for a lot of students is that teachers give you grades. And that's sometimes true for some teachers. That is not true for me. Literally, there is a rubric that goes from -1 all the way up to 6. Every single one of those numbers hints at something. It doesn't just hint at it, it tells you, it reveals your level of understanding to me. If you are scoring between that -1 to 3 range, there is little or no evidence of what you have learned. Or at least, and please understand, it doesn't mean you don't know it at all, but what I'm saying is what you have done there is showing me that, or I've seen little evidence of what you're supposed to know. If you're in that 3.5 to 4 range, I think I have it as limited evidence. If you're in that 4.5 to 5 range, you have shown me conceptual and procedural understanding, that there is evidence. And if you're in that 5.5 to 6 range, you have shown me clear, consistent, and convincing evidence of your understanding. There's no part of that, right, that is, Mr. Kinney is giving me a grade. And I bring this up because when I look at the understanding checks and I look at the test, for the most part, most of us scored at the same level or lower on the test than we did on our understanding checks. The whole deal I made with you is that if you learn from your mistakes, you grow and you get better, I will replace your understanding check grades. Heck, if you made an A or a B on the test, I would wipe out your missing homework grades. But those of us who had lots of zeros for homework grades are also the ones who made below A's and B's. What?
So that means if I make an A or B on the test, you wipe out all the stuff that I ain't do. That's basically what you're doing.
Yeah,
Has anybody else heard me say that a few times this semester?
you've been saying.
I've been saying it the whole semester.
I got a question.
Yeah.
On the test, did you, when you was grading it, did you like put the numbers and stuff like that, so when we do get back, we can look on?
But you had said, like, they had said, you was like, don't spend too much time trying to,
Say it one more time.
like, the damn test, you was like, don't spend too much time trying to, explain.
Did not say that. I said be efficient. Which being efficient means that you are still justifying, but you're not writing paragraphs upon paragraphs. It's being efficient. Remember I said if you have multiple problems where you're solving an equation, which there was 4 of those, you could just do one set of justification where I'm using the additive and multiplicative inverses to create the identities. And you could write that down as part of your justification and show that it goes for all 4 of those equations. I said be efficient with your justification. You still have to justify. You always have to justify. Okay? But being efficient is different. So, I need you to hear me on this because I sent an email to your parents. I can't remember if I sent you all an email or not, but I sent all parents an email saying, hey, look, we had the test. There's a little bit lower performance than I want to see, which means that it's lower mastery than I want to see on these tests. And I think I mentioned yesterday, if you do test corrections and you come to tutoring, then you will be allowed to do a retest. I am requiring those 2 things because I don't want to just regrade a test where you score exactly the same. So, I will leave the deal out there though that if on this test you show me greater mastery than on the understanding checks, then I will replace your understanding check grades with what you make on the test. I will wipe out your zeros on homework or grades that are lower on homework than what you did on the test. This is a deal to hopefully incentivize you to work harder and to learn from your mistakes, because you can do that. I'm working on creating a sheet of paper that identifies what overall major concepts you should be considering for each question and identifies the videos, because I will tell you this, there was not a single thing on that test that was not covered multiple days in this classroom. And I know that there was a lot on the test, but there wasn't anything on there that we haven't covered multiple days. Alright?
I'm gonna forget, like, the stuff that's on the table, like, we learned something.
Yep, we can't forget the old stuff though, because in math, everything builds. Which is why I'm asking you to do test corrections to learn from your mistakes before you do a retest. And I will emphasize and point out, a lot of this stuff with transformations, it should at least help us understand this better. The vertex form of quadratic function, right? Okay? So we should be learning from our mistakes and using the things that we're building on. And I need you to hear me on this. Fundamentally, the reason why I'm letting y'all do this is because I know that you are capable of more than what a lot of us showed me on the test. That's the plain and simple truth. You are capable of more than what you showed me on this test. And overall, I think a lot of y'all are capable of more than what you're showing me in general. Can you go to the, sorry for taking up so much time, but go to the response on the TI Inspire. So, no names or anything. A lot of us 3, none. Didn't really study, I just memorized. Stop memorizing, it doesn't work. I didn't study, I just went off what I already knew. I did not take it yet, so we do need that. Good amount, almost every day at like 5 to 6. I read the notes and stuff we done in class. I don't know who that is, but hopefully there's someone who did better. I want y'all to notice, consistently, what's the most common response?
I didn't study.
I didn't study. Oh man, I don't study. What should I expect to do? Poorly?
Oh.
If I don't study, I should expect to do poorly. You got to study, all right? Some of us watched the videos. I'm glad to hear that. A couple hours and did the worksheets I gave. Remember, I posted solutions to every single worksheet on Schoology, so you could have worked on the problems and then checked your work against mine. Come to tutoring, something. What I need you to hear me on is, if you struggle on this test, you need to change what you're doing. I have significantly changed my teaching from even last year to help support students to be more successful. But you got to learn this stuff and learn it well. Everything we studied was Algebra 1, and that's not to make you feel bad about it or anything, but my point is, We're supposed to have learned this in Algebra 1, and did it stick? No, Mr. Kinney, that's why we struggled. Yep, exactly, thanks guys. No, it didn't
I thought
stick.
you said didn't stick, I thought she was answering.
No, I said, did it stick?
My bad.
No.
No.
It didn't.
So clearly we gotta change what we're doing, okay? That's why I teach you differently than what you were taught in the past. But you're gonna have to go home and study. These graphic organizers, the point of the graphic organizers, big ideas graphic organizers, is not for you to just sit there and just copy down whatever you wrote in class. It's for you to look through all of your notes and reflect upon what you learned and reword it so that you're actually thinking. If you're not thinking, it's hard to learn. Everything I ask you to do is to help you grow and get better. We gotta take advantage of that. Still today, most of us have not finished the Mathia on solving equations. And we wonder why we struggled on that on the test. We didn't do what I asked you to do in solving equations and thinking about your inverses and creating those, or creating the identities, and we struggled on the test. You're capable of more, and I need you to hear me on that. You are capable of more, which is why I'm always going to fight for you to improve. And I will say, I am seeing every single day that we're improving on our thinking in class and our discussion. You're better than you were at the beginning of the year. But we got to put in some more work outside of class too. When I look up here and I see we didn't study at all, legitimately, and you may think I'm crazy for this, but I would recommend at least 20 minutes looking over your notes. And someone mentioned that I looked over my notes every single day. I would recommend at least 20 to 30 minutes every single day, because I know that the maximum classes you have is 4, right? A lot of us have 2 or 3. Take 20 to 30 minutes to look over your notes and reflect on what you did the day before. If you come in and you have a question at the beginning of class, Ms. Courtney and I will be more than happy to answer it. But that requires you looking back over your notes and reflecting. We've got to change the way we're studying. All right? Ms. Courtney is about to start the lesson for today. We're going to be reviewing, the stuff that we've done over the last few days.
Did you want to say that poll question?
Yes, thank you. We do still need to do that. So we're going to do a couple of quick poll questions on the calculators to get some ideas flowing and get us back in the groove. So get ready to pull those up, and then Ms. Courtney is going to review a little bit of what we've done the last few days. Did I not open it? No, here it is. I'll send it out for you. Just in the
Okay, and
future,
then
you just hit this start poll thing right here.
Okay. And it's.
Yes. So you put up those slides. So there is a poll question that you just got. This is what it's referring to. So can you talk with your group to help each other out? Heck yeah, let's do it. Let's get to discussing. Let's get to talking. It's on the calculator, but I have those 4 tutoring sessions every week. I got Monday and Wednesday afternoon, and then Tuesday and Friday morning. You're a new student?
Yeah. I actually first year.
Just
Yeah. I think I have your wife. I'm old.
I was gonna say, just from ACA?
Yeah.
Gotcha. Alright. I figure out what is, we just rearranged groups recently. Right now, let's have you jump into group 4. So get to know Kyle, Allie, Rosie there. I will, okay.
Yeah, they just threw me in here. I didn't.
Yeah, I didn't know you were. Huh?
That's not what I was saying.
They're all around.
That's what he said.
You got it.
What is the question asked?
Examine
No,
the
look at the
parent
question.
function and transform it.
Bro, I can't even see that part. You don't have a clue what parent function that would.
So it's talking about in this
Then you're
table,
not- yeah.
so what parent function do these points represent? Like these are the points, if I graph these on a grid, through that shape,
Yes, you can do
what
that.
parent function?
You can do it all. You can do it.
Zoom in.
Y'all, I need you to hear me very clearly. This Courtney has the tables up on the board. This is a parent function that you have dealt with. Talk with your small group. Try to figure out what this parent function is. It's not a hard one. It's probably the most common one you've dealt with. But I don't want to hear, I have no clue what this is. Talk with your group first. Think about the different parent functions we have of x squared, x cubed, the square root of x, absolute value of x. Oh, wild.
Is that better?
Wild.
Okay.
Yes, I did already know that. Hold on one second. Here's at least the resources for what we that you missed over. So, lesson 1 is we start on transformation of functions. And yeah, so you'll need to make notes on this somewhere. Lesson 2, we continue transformations of functions, and here's the parent functions. I'm gonna help you when I can. Shut up. Better get out of here.
Keep dropping out tomorrow morning.
May I get grabbed when I was reading this? Okay, do you want your shirt? Hold on a second. Yikes.
I got the question. It ain't involved in for that.
Dude, you haven't even logged into the calculator.
No,
You haven't even logged into the calculator. I'm not gonna answer questions until you log into that calculator. Oh, wild.
that's crazy.
That's crazy. Actually, can I get your, how do you spell your last name? D-E-A-R?
That's crazy.
2 E's, okay.
Right.
When you set up with a calculator, grab a laptop over there and a calculator in the back. Go ahead and start doing that. We need to be sure
Okay, guys.
Hold on. We have 25 students in here right now. 16 people have answered this question. We've looked at this question for 4 or 5 minutes.
Oh, I just.
Like, even if you just have to guess what parent function it is, get out your parent functions and type in an equation. There's only one parent function. So, that, I guess I should have clarified that. The function, the table on the left is the parent function. The table on the right is the transformed function. Yeah, you want me to flex it?
Okay, guys, so this table that represents the points for the parent function, what parent function does it represent? Okay, how did you guys know that it's the quadratic
Because
function
on
point?
the first lesson, it's like the exact same thing.
Okay, so you recognize that we use this table already. But, so, how could we confirm that this was a quadratic, that these were the points for the quadratic function if I didn't have a copy of the table?
The rate of change.
Okay, we can look at the rate of change. What did someone say?
It goes up and down, up and back down.
Right, but so what about, absolute value does that too. Okay, so think about how that shape of the graph looks and how that, those table points look. But also think about, remember guys, these points have meaning to them. So if I plotted all these points on the coordinate grid and connected them, what shape would that make? Right, it would make a problem. So that's how I can confirm that that this is the quadratic parent function.
So here are the responses, by the way, if we want to look at them. Which a lot of them updated, but I do want to point out, because I saw like square root on some of ours, things like that. If you take the square root of -2, do you get 4? Remember, we should be able to use that equation to go from our inputs to our outputs.
Okay, and then going, so we've determined that it's a quadratic function, so I went ahead and wrote this equation. So then from here, let's examine the two tables and see how these x values change, and then how the y values change. And then from there, we can create that equation. Okay, so can, let's see, Omar, your group, tell me, how do these x values change from the parent function to the transformed?
They add to.
So, talking about the x values.
Plus one.
Okay, so from this table, so from -2 to -3, how'd I get there?
Plus one.
Added 1. So guys, just so everyone's on the same page here, these are the things we're comparing. We're comparing from this x point to this x point. What change happened? Okay, from this one to this one.
That's minus one.
Plus one.
You're right. I didn't notice that. But y'all see that? It's -1 because we're talking about negatives here. And then going from 0 to -1, we're going
Down.
-1, down 1. Right. Okay, so we're subtracting 1 in what direction? Okay, horizontal, vertical.
Oh,
Okay, so since it's horizontal, I'm gonna have to put either a +1 or a -1 on the inside or on the outside.
On the inside.
Okay, so
Why we talking about why?
Me too, but
Okay.
I'm confused. Like, I thought you just said like.
She said X the whole
Yeah.
time. Pay attention.
yeah, we're talking about x. So x, and we said they changed, subtracting 1. But what do we have to be careful about when dealing with horizontal transformations?
Do add one.
They're opposite
Oh,
operations.
yeah.
Right. So what was another word we used for the opposite?
Inverse.
Right. So we're gonna use the inverse. So Anthony, what do I need to write after the x?
Plus one. Square.
Okay, so now let's examine how the y values change. So from the parent function to the transformed function, how did that y value change?
Add
Plus
two.
two.
Okay, we added 2.
Add
Is that
two.
consistent all the way down?
Yeah.
Okay, so you know that we are adding 2 and not, you want to check that it's adding by the same every time, because when you start looking at tables with dilations, sometimes you might be looking for multiplication. So the change would be different. But, okay, so we're adding 2, and this is with the y value, so what do I need to write next in my equation?
3. Plus 3. Plus
How many, Anthony, how many does it increase from this first y value to this first second?
But it's like the x value is 0 and then on 3.
We're talking about the y value. Huh?
Hold on.
Okay,
Oh,
so
no.
we're talking about where, like, so this function, would it help if we pulled up like a Desmos?
Maybe, but I would point this out. Where's the vertex in the parent function? 0, 0. So circle that vertex. Where is the vertex in the transformed function?
It's 0, 3.
0, 3.
0,
It's
3.
not.
No, it's not. He
No,
always
it's
said,
not.
he always said when it comes to a table, the vertex.
Well, it's not just that. Look at the y values. Wouldn't the vertex either be the minimum or the maximum?
The minimum.
What's the minimum y value?
2, -1, 2.
What's the
Two,
minimum y value? 2. Minimum y value is 2.
Yeah.
So that's my vertex, circle it. Remember, we already transformed the x value, right? It was x plus 1 squared. We're doing the y value separately. But Anthony, you see how that's the vertex?
So this is what
Let's
Talking
pull up
about
a,
graph it.
graph it, yeah.
That's how I got it last time. I just
Or do you want me to use that
0, 3,
slide
so I just
6?
put three.
That's fine.
Leave me alone. It's not funny, guys. Oh, ooh. Oh, punch both of y'all.
Alright,
it will log me in automatically each time.
So, and there's a few of each of them on my
You have to look at the x separately and the y separately. X is horizontal, y is vertical.
So why was I doing this? We used to do it like that. That's how we did it. Why except on
Which one has the You can't do that.
We're not doing it.
You know we still haven't taken that test.
So
what? You know we still haven't taken that test.
Who's
Right?
that?
I know.
Yeah, no, you got this.
See, I barely
You
do
gonna
on
write
that.
that table
I
down?
just know her that y'all was together and she already on there. How you put up?
No, you don't need the code yet, we're still going over the bell ringer, guys. Just write that table off to the side, and then look at the graph. Guys, I might suggest writing this down as well. If you're struggling and confused with this, it's probably something we should take notes on.
So it always goes in the middle.
Not necessarily.
So how can you tell if it's the vertex?
Okay, guys, so. Okay guys, so I'm using this, the slide we looked at the other day, kind of just as a reference to show you what's happening in this transformation of these tables. So, when my functions are like this, the equation for both of them is y equals x squared. Okay, does everyone agree? Okay, so now, if I'm creating a horizontal translation, which slider should I move? Which slider?
D.
Okay, and then, so do I move it +1 or -1?
+1.
Okay, so what's my new vertex? So the vertex of the blue function, so the blue function's my transform function. Okay, and then what, so I need to change this vertically too, vertically also by how many? What is my equation? Okay, so what's the coordinates of my vertex now?
-1, 2.
Okay, so does that, and then so look at the table. Remember in the table I had these two circled, because this was the vertex of my parent function, 0, 0. And then the vertex of my transform function after I move it to the left 1 and up 2. Okay, and similarly, the values of all the other points moved over 1 and up 2. So from that table we had negative 2, 3, negative 3 6s up there, 0, 3, and then 1, 6. So y'all see, like, this is what I was kind of talking about yesterday, is these points are not random, and even when you, so you guys remember on that understanding check Friday, when you had a coordinate grid and it said graph the parent function and the transformed function? Well, one of the big things I noticed is people would graph, like, the point of the vertex, and then they would just draw the shape of the parabola with no, like, none of these other points had any meaning or place to them when they need to. So, like, going forward, when you have assignment or questions like that, you need to make a table or have some kind of like organizational thing to where you know what each point's supposed to be plotted, or like how that exact shape's supposed to be.
What are y'all's questions at this point?
None.
For you, maybe.
Ain't nobody else answering. So, none. If they ain't got no questions.
When we pause, is a good time for you to ask questions. Remember, that's part of the active collaboration that we're looking for too.
And then, so maybe guys, another thing is, as we're gonna be going through our Desmos notes again today, we're gonna be revisiting some of the tables that you should have created already, so it won't take long to just look at them. And today we're gonna focus on really just analyzing, like, parent function table to the transform function table. Like, we're analyzing these changes and we can create the equation based off of that. Yes.
So the red line, they move.
So,
All the time.
right, because the red, that's our parent function. So in this blue one, I'm showing the transformation of the red one.
So you only basically calling out -1 plus 2. You ain't really calling out the other ones. That's on the other one.
So
Yeah.
I did talk about, so these moved, so this -1, 1, it moved over 1 and up 2 as well, and this is the new point. So each point moved over 1 and up 2, collect, like, together to get those new values. Does that answer you? What you're confused about? Does anyone else have any questions? Okay, so, start the Desmos.
I think we had the slide set up, didn't we, to go through that?
Oh, yeah.
And then once we got to that slide is when we had the mixed learning and Desmos. So you need to have lessons 1 and 2 out that Miss Courtney went with us. We're gonna go over a couple things to make sure we have solid notes, because when you don't have solid notes, it becomes really hard to study. So this is slide 4 from lesson 1.
Oh yeah, and kind of like Mr. Kenny just said, another main reason we're kind of going over this is to make sure everyone has the correct notes for, like, all these main idea questions and things where you're supposed to notice these patterns, because this is going to be important to study later. Lesson 1. So you chapter lesson 1 notes. Slide 4.
I know you have this here.
Okay, guys. So going back like a week now, this is kind of where we started off learning about these function transformations. So by looking at this graph, or if you want to look on your computer screen if you're on the Desmos, it's the same. Have you not been logging in? Have you not been logging in? Like, if you log in, it should save to your.
No, you still gonna have to type these guys.
Oh, you do?
You don't have to, but we'll go back to it in a second. Just focus on these notes for now.
Okay, so just by, everyone can look up here, just by looking at from, okay, so remember the red one's my parent function and the blue one's the transform function. Okay, so what kind of transformation happened when I went from the parent function to the transform function? Okay, so I had a horizontal translation, in what direction?
Right. It's -3.
To the left 3, right? Or to the left 3, correct? So, let's create the table, or you should already have this table filled in for your parent function, but now would be a really good time to make sure all these values are correct for your table. Okay, and then so when I have a horizontal translation, what values change?
The X.
Right, so, Kelsey, what values can I write for the Y column over here of the transform function?
I know, second,
Yeah, no.
7,
Okay,
4,
guys, we just said, what values change?
The X.
The X values change, what do I write for the Y value?
oh, I just asked you, was you talking about X or the Y, you said X.
Oh, I'm sorry.
Yeah, my
I
bad.
thought you said it, okay, that's not what I said. Okay, so now, Dawson, were you telling me the X values? No? Okay, will someone give me the X values?
-5. -5. -4, -4,
Oh,
-3, -2,
Okay, so yeah, guys, make sure I'm on slide 4. Okay, so from here, you shouldn't have stopped here after you wrote the tables. You were also supposed to, well, okay, I guess it doesn't say create equation, but I had put these little equal signs here and left this space, like, thinking you guys, which I should have wrote that. But, so this is y equals x squared. Okay. Okay, so why am I putting in my transformation on the inside of the parentheses?
Because it's a horizontal chain.
Okay, does everybody besides Anthony and Jakayla understand why we're putting it on the inside of the parentheses? The x minus 3, or what is that? Plus, x plus
Yeah,
3
you
on
gotta
the
flip it.
inside of the parentheses. Okay,
On the inside is minus. X minus 3. Because you're going to the right.
well look where we went to the left. We started here. And then also if you look,
Oh,
so
right.
look at how did our vertex change? We started at 0, 0, and then our new vertex was to the left 3. Okay, so when we answer this question, what do you notice about the corresponding coordinates of the points of the transform function in relation to the parent function? What can we say about this like how can we say this mathematically?
The Y value are the same on each.
Okay, right, we can make that note. So we said the Y values are the same. So that indicates what kind of change?
Horizontal chain.
Okay. Okay, and then now guys, we can also talk about how the x values have changed because that tells us what kind of transformation we have, right? So how can we say that?
They both have different X values.
This value decreased up there.
Yeah.
So the x values decrease by 3. So this would be what kind of transformation? Right, translation. Okay, because remember I'm talking about transformation, I'm asking how did it move? Did it translate, dilate, or reflect? And then when we're talking about direction, this is when we're talking about horizontal, vertical. So the x value decreased by 3, so you can say the function translated to the left.
So when we're talking about if it translates or the other two.
Those are the transformations. That's talking about how this, the function, how the transformed function is different from the parent function. Okay, and then remember those operations of either addition, subtraction, multiplication tell us what kind of transformation happened. Okay, so having this kind of explanation down is something you want to write and you want to study and you want to start practicing talking about the transformations like in this way. You want to be specific to the kind of transformation and the direction and like why these things are happening. What values are causing this this change? What operations are we applying here?
Wait, were you actually asking the question?
No,
Oh.
I'm just talking. What? Yeah, the next one. Okay, so then now guys, look at this question. It's on your page 3. Okay, so now let's make sure we all have a, like,
They have this on the graphic organizer from yesterday, don't they? Or do you want to go over it just quickly?
yeah, that's fine. Okay, so talking about the location of the addition and subtraction. So if I have a addition, which we've kind of already talked about this morning with our Bellringer question, so adding or subtracting on the inside of my function's main operation is going to cause what change?
Horizontal.
Right, horizontal, and since it's horizontal, we do have to consider the inverse direction, right? And then so, let's see. Jenny, so when the function is being, or when something's being added on the outside of my function's main operation, am I going to have a vertical or horizontal change? So I'm adding on the outside of my function's main operation. Sharnavia, can you help her out?
It's a vertical.
Right, so that would be vertical, okay? So these are notes you should have on your graphic organizer from yesterday and also under this question of the Desmos notes. Anything want to add to that for this thing?
Just, yeah, don't forget if it's,
Hold on.
if the operation is inside the main operation, or is inside the defining or main operation, it's a horizontal transformation, and it acts the inverse of how it appears. And if that operation is outside, it's vertical, and it acts exactly the way it appears.
Right, so we made those distinctions yesterday on that graphic organizer.
So I think you wanted to let them work on this one, didn't you, for a second?
Yes, okay guys, so in your group, so you're given these two tables. This is very similar to how we just did this little poll question. This is the table of the parent function. This is the table of the transformed function. This is also on your paper on the practice problems on page 4. Okay, so you're looking at page 4 from day 1 with your group. take a few minutes, analyze the tables and the changes, and then create an equation for that transform function. Okay, like 2 minutes.
It's practice on page 4.
Page 4. Yes. Yeah, great.
Let's go.
We're not
Don't
really
worry.
right now.
Let's go. Just talk about it outside of that.
We're doing it right now.
What number are we on? Page what?
You're doing student algebra split.
Or July.
So this would have been all from like lesson 1's notes, like a week ago. Okay.
Yes. I logged in already,
Well, we're not really using this right now, just like the practice problems, and I'll get you the thing when we come back to the actual activity.
Hello.
Hey, do we know where that Zoom coming from? It's literally plus. It's right.
The first thing
You see what
oh, we're not gonna be here. Is this the equation?
Okay, guys.
No, we starting.
I'm gonna block.
Yes. So when you go from 0, from this 0 to this 6, you added 6, right? Okay, guys, let's come back up here for a second. Okay. So looking at these tables, which in this one I gave you that this was the table for the quadratic parent function. Mr. Kenny will not give you that information probably. You have to know that this is the quadratic parent function table. Okay? So going from here to here, did my x values change or my y values change? Okay, so we're really looking at these x values. Because this one only had, so in the other question you had a case where both changed. Here we're only doing one. So we're only looking at these x values first. And then, let's see, Dawson, your group. What was the equation you guys came up with?
X minus 6 squared plus 0.
X minus 6 squared. Okay,
You gotta put the 0 there?
no. And I was about to ask. So guys, that 0 is not necessary. It literally does not change the meaning or the shape or the position, anything of the graph by taking that plus 0 away. Okay? So was everybody able to get here? Was everyone able to create this equation? Okay, so if you were not able to create the equation from looking at this table, you need to go through those questions where you ask yourself, what changed, and then by how much? And then since we had from this, if this was our vertex, from this x value, we were from 0 to 6. So that's an addition of 6. Huh? Because it doesn't change anything.
You want to write it right?
Yeah. So from this 0 to this 6, we added 6, but since we're dealing with horizontal, remember you have to put a minus in the middle, or a subtraction sign. Okay? So then, okay, so now this is another question that deals with 2 transformations. So take another couple minutes with your group to talk about how you create the equation for this situation.
That's easy.
So this is the question right after the other one you just
Can we
looked
make a
at.
table?
Say it again.
You making a
Can
table
we make
or
a
an
table
equation?
for it?
So it says, so,
That's what I like.
You can make a table to help you. I think we're asking for an equation here.
yeah, so the answer is gonna be in the form of an equation, but you can use a table to help
Right.
support that or develop your ideas for it.
So will the parent function table ever change? Nope. So you can use those transformations to help make a transform table, sure.
It is plus one. Plus one. Hey, you put something else. We wrote it right in there.
No, so the function, it was a horizontal transformation. Yeah. So you can say horizontal or transformation.
When you say over, what do you mean? Okay, so horizontally, but which direction?
I already gave it.
Square man.
To the left. It says to the left.
So that would be saying, that's
But
multiplication.
I think you're also thinking like, where would that transformation go? If it's horizontal, remember there's two places,
Now I'm
either on the
validating
inside the main operation or the outside.
Oh.
Kylie, if it's horizontal, is it inside or outside the main operation? Do we all agree though that if it's horizontal, it's inside the main operation?
So think about, what's the function
Notice
main
you need to remember, like, you already know this. So it's x, you say it's on the inside, so what's it gonna be? X
What is it, what are we talking about? We're talking about the function's main operation.
minus or plus.
That's not what it means by the, what's the function's main
Minus what?
operation?
Squared and then plus 7. Okay, I want you to re-examine that, because I need you to remember, one of those operations, or one of those transformations acts the inverse.
This not gonna change, because it don't change.
Okay.
You get what I'm trying to say?
But-
No, in the short, it don't change, they don't change, this change.
Okay, so did you do that?
Alright,
But if you said that, but it's saying
But it's to the left. Right?
oh, okay.
That'd be to the left.
I got it.
okay guys, so if I'm starting off with this parent function, y equals x squared, okay? Kyle, how do I show a translation of 4 units to the left?
Oh. Y equal in parentheses x plus 1.
Okay? Am I missing anything here? Yes.
Square plus 7.
Okay, squared. Okay, so don't forget that functions define, that square is the defining operation. That's what tells me that this is going to be, it looks like a parabola on the graph. And then we're adding, we're going 7 units up, so I'm putting this plus 7. Where is this plus 7 in relation to my function's main operation? On the outside. Okay? And then so this x plus 4, remember even though we went 4 units to the left,
Swap the sign.
Inverse of
you have to think of the inverse when we're dealing with horizontal changes. Okay, so that's why it was x plus 4 on the inside.
Alright, hold on, time out. Let me write that down.
Okay, write it down, circle plus 4, or like make notes, this is to the left. Like tell yourself you're doing the opposite, like you're having trouble remembering these things.
Is there any idea that we've already studied that connects to?
vertex.
Oh.
It just don't have an A to,
Well, what's the A understood to be?
X. Y.
One.
1.
oh, okay, yeah. But, nah.
So we're gonna
So you don't
do,
need to write it, because it's one.
so we're gonna use vertex form for the whole.
Yeah, this is the equation.
So now for like,
That's it. It asks you for an equation.
not to know